Okay, so we are looking at perpendicular vectors. So this is, we can quite often get asked to prove if vectors are perpendicular. And we can use this in 2 dimensions. We can do this with gradients that we will do later when we get to the straight line section. But there's another method which can be used, which is using the scalar product. And that's what we're doing now, and that can be done in both 2 and 3 dimensions. So if we look at our first formula for the scalar product, we have the scalar product, or the dot product of A and B, is equal to the magnitude of A times the magnitude of B times the cos of the angle in between them. Right, so we know that if angles are perpendicular, that means that the angle between them, so we had 2 vectors like this, that the angle between them is 90 degrees. But we also know that the cos of 90 is in fact 0 from our cosine graph. Our cosine graph goes like this. And we know that at this point here, that's our 90 degrees, and we know that it is when x is 90, y is 0. So that means that we're going to have the magnitude of A times the magnitude of B times 0. Okay, so for perpendicular vectors, so for any perpendicular vectors, or so for any vectors to be perpendicular, the scalar product must be equal to 0. Because the angle is 90, so that means that we get the scalar product to be 0. So there's 2 different ways that we can do this, that we'll get questions on this. We either get told, prove whether or not these are perpendicular, or we can get asked to find part of a vector to make them perpendicular. So first example, if we've got u, which is going to be 3i plus 2j, and we've got v, which is equal to 2i minus 3j plus 4k. Okay, and we're going to show that u and v are perpendicular. Okay, so remember, any question where they say show that means that they want a sentence at the end. Okay, so what we want is we're going to do the dot product of those 2. So to do that, we'll just quickly put it into component form. So 2 minus 3, 4. So remember, to do the dot product, what we do is we times the x components together, so we get 3 times 2. And then we add on the multiple of the y components, so we multiply the y components together, so we get 2 times minus 3. And then we get to add the z components, which is 0 times 4. So we're getting 6 plus minus 6 plus 0. So that is 0. So therefore, the dot product, therefore as this is equal to 0, so as the dot product of u and v is 0, the vectors are perpendicular. Okay, so that's it for those kind of questions. So if you get asked to prove that vectors are perpendicular, all you have to do is find the dot product, and you're going to be using the second formula that we've got, so this one, to find if we get 0. Right, okay, so the next type of question we can get with perpendicular vectors, we can be asked to complete a vector to make it so that they are perpendicular. So we get told the vector is perpendicular and we have a missing piece of information, or sometimes a couple of missing bits of information from our vector, generally with the same letter though, because we can't solve them if there's 2 unknowns, we can only solve them if there's 1. Okay, and we can use these to find out the last bit of information. So where this is, so we've got A, which is 1, 2, K, and we've got B that is -1, 4, 3. Okay, and we get told if these vectors are perpendicular, then what is the value of K? Okay, so we know, so for our answer, if perpendicular, then that means that A dot B must equal 0. Okay, so therefore, so like I'm saying, I'm talking through the question, you should be trying to talk the examiner through your questions with how you lay out your working. Right, so A dot B equals 0, which equals A1, B1 plus A2, B2 plus A3, B3. Okay, so we get 0 is equal to 1 times -1 plus 2 times 4 plus K times 3. So we get 0 is equal to 1 plus 8 plus 3K. So 0 equals 9 plus 3K. Rearranging to get what K is, we've got to subtract 9 from both sides. So we get that 3K is equal to -9. I've just moved the 3K and the -9 to the other sides of the equal sign, but that's not a problem. Okay, and then we divide by 3 to get the K on its own. So we get that K must be equal to -9 divided by 3, which is -3. Okay, we could be asked to use simultaneous equations for these, but it's unlikely, so just a note there for you that you could be asked. So you could get told that it's perpendicular to 2 different vectors and have to work them out. Okay, but we should remember how to solve simultaneous equations from National 5, and there's nothing else to that that's any different. Okay, so I'm not going to do an example of those, but if you really want an example, leave a comment and I will make an example for you, like I'll do an example as a reply to a comment. But that is us for perpendicular vectors, so it's just where the dot product is equal to 0, that means that the vectors are perpendicular, and we can use the reverse of that to say if they are perpendicular, then that means that the dot product must be 0. Right, so if you've got any questions, leave a comment, let me know if there's anything you think I can improve on the video as well. Like, comment, subscribe, all of those things. Okay, thank you.